All right, and thanks for tuning in. Welcome, everybody, to the Daily Space Weather. I'm your host, Dan, a.k.a. smAsho, and we've got lots of busy stuff to talk about today. Let's get to it. First thing we're looking at here is the sun. No surprise there. This is 171 angstroms and the colorized magnetogram imagery from the Solar Dynamics Observatory. And we've seen some coronal mass ejections, some solar flaring happening. We've seen a proton event, lots of stuff to talk about. There's an annular eclipse going on as we make the video as well, so we'll try to keep it a little bit short and encourage you all to go out there and see the annular eclipse if you have a view of the sun, clear skies, etc., a view of the horizon as the sun rises in places like the mid-Atlantic states. So one of our custom helioviewer movies we made today was this one. It's 94 and 171 angstroms composite. I just sort of selected that because I thought it might show some great imagery, and indeed it does. And I would attract your attention up here in the northwest corner. We've got some fascinating close-ups of that. Also some activity in the... So we've got activity in the northwest corner as well as in the southeast corner. Two sunspot groups. We'll get to it. 304 angstroms is one of the most spectacular views. You can see that incredible solar prominence happening up there in the, actually in the northwest and in the southwest. You can see a second prominence down there. And some of the ejecta from this event has already made it to Earth, believe it or not. We'll tell you all about it. How about some close-ups? Here's an extreme close-up of this incredible prominence that we saw. Along with the Earth scale to show you the size of these giant magnetic loops of ionized helium, in this case 304 angstroms. Just spectacular imagery there. And this did indeed catch some of us off guard because, well, we'll cover it here in a minute, the view from Lagrangian point 5. So out here at Lagrange point 5 where stereo A is located, we've been seeing darkness over the past few days at stereo A. Although we do have enough information here to show that indeed most of the ejecta will miss Earth, and some looks like it is directed at Earth. So right on these images here, you can see there is plasma headed out the pike toward Earth, which is in that location from stereo A, although most of the ejecta is on the far side of the sun. You can see it out there. So a little bit of a coronal mass ejection is going to be forecasted here. Hopefully we covered it first. And here's what's going on in the solar system. Happy new moon, happy annular eclipse. There's where things will be in 1 week. Here's a star chart, and when we see the sun rise, it's going to rise along with the moon, aka an annular eclipse. Annular eclipses happen, folks, because the moon is too far away to completely cover the solar disk. And we'll animate this imagery. And you can see the moon and the sun overlapping there. It's annular eclipse day. The 10.7 centimeter radial flux, the outputs of the upper chromosphere and lower corona, are at 79 solar flux units. Here's a one-year chart of that. The black line is the 10.7 centimeter radial flux. It's the most proportional number we have to sunspot number. No storms forecasted right now. We'll have to wait to see what the telemetry is for the coronal mass ejection. We had no ability to predict this one. It was pretty unexpected, and we did see relativistic protons show up quite promptly. Let's take a look at global seismicity. We've seen a lull in seismic activity, despite some major coronal mass ejections, including one that sent protons all the way to planet Earth. No earthquakes over a 5 magnitude over the past 24. There are the sorted by 4+ magnitude earthquakes from volcanodiscovery.com. Here's the USGS site, and we're going to scroll up the list here. Not a lot to cover when it comes to earthquakes. Well, indeed, there was a 5.0 there at Japan. Nothing to write home about there. A deep quake at the Philippines at a 4.5 magnitude. No big deal. Fiji saw a deep quake at nearly 600 kilometers, 600 kilometers depth. Magnitude there only 4.5. And continuing on, if we left anything out of the coverage here, just leave it in the comments. Let us know, as the conversations often continue for days in our comments section. We do read all comments. So a couple deep quakes happening here just recently, such as this 4.4 at Tonga and this 4.0 at Afghanistan. Let's check volcanoes. And we see some new additions to the list once again. Mount Ibu's exploding, 6,000-foot ash plume there. Semeru. Previously reported high-level possible ash cloud turned out to be meteorological in origin. VAAC Darwin canceled the advisory at Semeru. Sangay exploding, producing a 20,000-foot ash plume over Ecuador. And Revenador has dispersed its ash over that same country. Sabancaya in Peru, intermittent emissions there. And Pele, actually I believe it's pronounced because of the accent, Pele, remains restless. So that's in the West Indies, folks. And we saw some seismicity there. Quakes occurring inside the volcanic edifice at altitudes between sea level and 500 meters, likely showing movements of volcanic fluids such as gases, hydrothermal water solutions, or small amounts of magma. A prime example of a reason to not pole vault the caldera. This public service message brought to you by smAshomash.com at great personal risk and expense. Don't forget to visit smAshomash.com, check out our links, support our channel. Next, looking at the GOES X-ray flux here, we saw a C-class flare happen right as I got out of bed. It was actually happening before I made coffee while I was reading certain news articles and so on. Anyway, that's the 3-day chart of the GOES X-ray flux. The GOES 16 has sun-facing suites of instruments and earth-facing suites of instruments. These are the sun-facing suites of instruments. And we saw a minor proton event here. So the coronal mass ejection that we were showing you earlier in the video did send some relativistic particles. And if you look here at the X-ray flux, so these particles must have been associated with one of these two coronal mass ejections here, as it took only a few hours for those protons to make it to the GOES 16. So there you go, a little minor proton event. That's the fourth proton event from cycle 25. Solar cycle 25 being covered in depth by our channel. Now, solar flares can cause radio blackouts. And what you're looking at here is the deabsorption region of the ionosphere. So the lower depths of the ionosphere, the lowest layers, can sort of open up, and instead of re-emitting your radio signals, it can absorb your radio signals, and that's what you're looking at here. That's a radio blackout associated with a C-class solar flare this morning. And if you want to look at these yourself, it's the deabsorption region predictions. You can find all of that stuff at the Space Weather Prediction Center. A whole bunch of links down at the bottom of those pages. We regularly use them in the daily videos. Here's a 3-day chart of the GOES magnetometer, and we're seeing a little more normal readings here. Let's take a look at the heliospheric current sheet and check things like polarity and activity. So here is the top view ecliptic plane field plot. It's a bunch of magnetic data derived from 51 ground-based magnetometers and magnetometers on stereo A and stereo B. One of the best insights into what's going on with solar activity. And there is some activity out here by stereo A. You can see this bunched up plasma here. Earth is solidly on a south pole current sheet shown in red. Let's continue on to show the line of sight ecliptic plane field plot. There you go. And you can see some powerful magnetic field force lines here on the opposite side of the sun. Those North Pole oriented strong potential field surface source lines showing up from the other side of the star. Here where Earth is. This data is 1 hour and 53 minutes old. Keep in mind the magnetic environment can change suddenly, as the coronal mass ejections we saw last night were stark indicators of. Here's the line of sight coronal hole plot, and you can see some more south-oriented coronal holes rotating in. North one's not looking so defined anymore. And we can expect some coronal hole wind from those in about 4 or 5 days. depending on how they continue to play out, we'll be watching them. And here's the detected filaments and sunspot groups. There are still filaments in between Sun and Earth, folks. We could still see additional coronal mass ejections, but in any case, we've got two sunspot groups, 2832, beta class, and sunspot 2829. Beta class, the possibility for solar flare still remains, more likely from 2829 due to the Earth facing quiet, which is about to expire later today from sunspot 2832. KP index, a measurement of global geomagnetism, currently at 0, as we see fairly weak solar wind conditions. Continuing on to the real-time solar wind, give it a minute to load. It's an interactive applet. Current conditions are 6.83 protons per cubic centimeter for the solar wind density. Solar wind speed only 344 kilometers per second. Nothing to write home about there. Let's take a look at geospace magnetosphere movies. It's 4 hours of data. Magnetohydrodynamic pressure modeled in nanopascals. It's part of the space weather modeling framework. We see a fairly homogeneous magnetohydrodynamic pressure around the Earth geospace here. You're looking at about 12 Earth diameters of geomagnetism surrounding planet Earth. And if you've got theories as to how Earth's geomagnetic field is generated, leave us a comment and let us know what you think. Here is magnetic perturbations on the ground level, otherwise known as geospace delta B. This is shown in nanotesla, the actual magnetic flux itself. And we show this daily since we are living a polar excursion, when the Earth has seen its North Pole split in two and the South Pole leave the Antarctic continent and end up someplace south of Australia. Anyway, like the last magnetosphere movie, that's 4 hours of data based on the space weather modeling framework, courtesy University of Michigan. Now, we do regularly stream live to Twitch. Today we'll be streaming live to Twitch for the meteorology segment. Check out our Twitch channel. It's twitch.tv/smAshomash. They've got a great mobile app. If you haven't checked that out, it'll notify you when we do live streams on Twitch. Again, we'll be streaming live for today's meteorology segment. Did you check out yesterday's weekly smAsho stream AnyChat? We'll be doing a Wednesday afternoon live stream every Wednesday. We just started it yesterday, the inaugural edition. It got demonetized. So check it out. You can find that on our playlists, youtube.com/smashomash/playlists. Thanks to our new subscribers over on YouTube. We greatly appreciate your pressing like, pressing subscribe, and pressing share, telling your friends and foes about the content on your social media. Cheers. And again, don't forget to check out our playlists, youtube.com/smashomash/playlists. Some of them are quite spectacular. Also, don't forget to check us out on Twitter. You may see exclusive content there, thanks to everybody who filled out our poll about who's more important, Vladimir Putin or Joe Rogan. Welcome to the DR Renaissance. Don't forget to visit our own website, smashomash.org. We'll redirect you here to smashomash.com. You can find our social media links there. And check out our smAsho merch shop, which will direct you to here. We've taken a 5% hit on our profit margins for the entire month of June. Whoops, we screwed up. We're taking a smaller cut to make it more attractive for you to check out our products. There are 7 designs. Again, you can link directly to the Redbubble shop Smash team from the Welcome to the Neo Renaissance homepage, smashomash.com. Click on the smAsho merch. Discounts all through June at our Redbubble shop. The designs are high quality to say the least. And if you haven't checked out our cosmology segment today, check it out. We talked about changing look blazars and the annular eclipse that's going on as we make the video, and more. That's also available in our playlist, our cosmology segment. And let's get to talking about electrons. The Earth is surrounded by them, and they give us insight into the Earth's geomagnetic field. Currently, we don't see any charging hazards caused by a surplus of electrons. Here's the 1-year chart of the electron flux. Seeing pretty low levels going on right now. And here's the 3-day chart. Nothing to write home about there, fairly low levels. And here's the forecast model. I would disagree with this forecast also. I'm expecting tomorrow to see higher levels of electron flux. Not sure what NOAA's talking about there, but anyway, the green boxes are the forecast by NOAA, and the yellow diamonds are not Lucky Charms marshmallows. Those are the observations. Next, looking at the total electron content forecast, this is showing you electron density all the way through the entire air column, from a GPS satellite potentially to your handset, giving you indications of where errors will occur. Electron belts are looking slightly incoherent here at nighttime. I'll let it play through a second time. This does indeed give you good insight into the likelihood of seeing electron flux-induced GPS anomalies. Since it refreshed, I'm going to let it play all the way through. It's your total electron content forecast. And here's a diagram of the Van Allen belts. Feel free to pause the video. Distances are in miles. Here's another diagram of the atmosphere showing you where the F ionosphere layer is. It's at about 300 kilometers of altitude, and here's an animation of that. One slice of the atmosphere. In many ways, the bridge between Earth and space, the ionosphere, and we're seeing some quite significant anomalies here in the South Pacific Ocean. So if you look down here, you can see some sudden vibrational charge ups here, right there. Some big-time vibrational charge-ups in the ionosphere there. Western South America and the South Pacific, right there. Unexpected ionosphere charge-ups. Anyway, here's the latest image coming through at 9:15 Universal Time. Things looking normal around that moment. And let's do a meteorology segment, which will be a separate video. And let's do bonus features on the daily space weather. First thing we're going to show is some ground-based observatory data. Let's see what's being seen from Udaipur, India. Better yet, let's check Spain. El Teide showing a dark screen. Is it because of an annular eclipse happening? I frankly have no idea. Let's go back to Udaipur, India. Again, 2 sunspot groups, folks. There are still significant likelihood of coronal mass ejections as well as solar flares from those groups. There are still significant filaments suspended on the sun. You can see some of them down here, some of them out here suspended off the limbs. The likelihood of those to eject is still as significant as it ever could be. Here's the latest intensity gram in high resolution. Sunspots are both looking pretty weak. They're both still beta class, I believe. That's still beta class as well as that. Here's the colorized magnetogram. We'll press refresh. And these areas down here do not appear to be sunspots yet. Let's just check. Nope, no umbre there. Thanks to our patrons, the true source of funding for the content. Without our patrons, these videos might not exist. You should thank our patrons as well if you're viewing the videos and not currently sending us any cash. And consider becoming a patron even if you're too lazy to open your cobweb-encrusted wallet and send us a few bucks per month, because we put up many posts publicly. Patreon.com/smashamash. Thanks again, patrons. Here's a full disk view in 171 angstroms of the past 24 hours of solar activity. It's my favorite wavelength. If I had to pick one, I'd probably pick this one. And here's some spectacular imagery of the coronal mass ejections that we talked about earlier. Spectacular imagery there. This is the SDO, as well as the Soho LASCO C2 and C3 composites. Here's a slightly closer up view of the same. I think we've got one more to close things out. Nope, that's it, folks. Thanks for tuning into the Daily Space Weather. Remember to stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Thanks again for watching, and may that solar wind be at your back. This video brought to you by Smash News Network. Least busted name in news.